Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, 2015 question on sequence and series. Mary threw a ball onto level ground from a height of 2 meters. Each time the ball hit the ground, it bounced back up to 3/4 of the height of the previous bounce as shown. Complete the table below to show the maximum height in fraction form reached by the ball on each of the 4 bounces. Okay, so we can see that the maximum of this one, so it was dropped from here, so the maximum is 2 meters, okay, or as a fraction 2/1. The height of this bounce here is 3/4 of that. So 3/4 of 2 is 3/2. Okay, or 1.5 meters. The height of this one is 3/2 multiplied by 3/4. So 9/8. 3/4 of that is 27/32. And 3/4 of that, 81/128. Okay, so they are the heights of the bounces. Part B then said find in meters the total vertical distance, so up and down, the ball travelled when it hit the ground for the 5th time. Give your answer in fraction form. Okay, so it hit the ball once here, and we had travelled, so just here it hit the ground once here, and it had travelled a vertical height of 2 meters. Okay, the next time it hit the ground was here, so it had gone up 3/2, down 3/2. So 2 times 3/2. So that was the it hits the ground for the 5th time, so 1, 2. So this is the 3rd hit, so it's going up 9/8, down 9/8. Plus twice 27/32, plus twice 81/128. Okay, so put that into your calculator. So I am getting, give your answer in fraction form. 653/64, if I have put that in right. Okay, so that is the distance that it has gone in 5 bounces. Okay, if the ball were to continue to bounce indefinitely, find in meters the total distance it would travel. Okay, so this word indefinitely, okay, there is a specific formula for something that happens indefinitely. Okay, so the first thing to note is that this particular sequence is what we call a geometric sequence, and it's that because there's a multiplication factor between each term in my sequence. Okay, so if I go to my log tables and I go to the sequence and series page, you can see I have 2 types, an arithmetic sequence and a geometric sequence. So this one is a geometric sequence. And down here on the bottom are 2 what we call SN formulas, SN being the sum of the first number of terms. This SN is the sum of whatever your n is. It could be 2 terms, 3 terms, whatever. And this is s to infinity. So it's kind of hard to see the infinity symbol there. Infinity meaning lasting forever. So this s infinity equals 1 over a minus r. So s to infinity is equal to a times 1 minus r. Okay, if I go back to my log tables, you can see a is the first term and r is my common ratio. Okay, so I would say in this one, my sequence is 2 plus 2 times 3 over 2 plus, well, let me factor out that 2 because that might make more sense, plus 9 over 8 plus 27 over 32 plus ... Okay, so if I get the sum to infinity of this, because really that's the part that is running indefinitely. Okay, so if I say my first term there is 3 over 2, and my common ratio, what am I multiplying it by each time? It's 3 over 4. Okay, so let's put that into my formula. Sum to infinity is 3 over 2 over 1 minus 3/4. Okay, so hit your fraction button, 3 over 2 over 1 minus 3/4. Okay, so I'm getting 6 for that. So if I put that into my sequence, and from here I get 2 plus 2 times 6.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.